Hi everyone, Bernardo here. If you've been following us, I've been talking with my colleague Aro about LLM system evaluation, how you could use LLMs for evaluating other LLMs, the concept of LLM as a judge. And today I'd like to share with you an interesting approach to LLM as a judge. So the paper we are going to be looking at today, it's called Prometheus 2, an open source language model specialized in evaluating other language models. The main idea here, the main idea of the paper is basically creating a language model that could perform as well as a strong closed source language model in the LLM as a judge task. Right now, the standard option for LLM as a judge is using closed source proprietary language model like GPT-4 or Claude. But the authors here wanted to try with an open source language model for evaluations. And what's the reason for that? The reason is that if you're using closed source LLMs, you know that these models are not super transparent. They are behind API. We don't have access to the model weights, to the data, so there's no transparency. They are not controllable either. And what we mean by controllable is that even if you're using GPT-4, OpenAI, for example, could be rolling out new versions under the hood for running A/B tests, etc., and that could basically impact the correlation of your judge with your judgment. And then also, in the long run, if you are like using many tokens for evaluations, it might be that these closed source models for LLM evaluation are not affordable. That might be another concern. So is there any open source LLM that could perform well as a judge right now? Well, the open evaluators available now suffer from low agreement between the humans and the evaluations. That means that, let's say that you are annotating this specific data point, the judge, based on an open evaluators, is giving a score to that data point that it basically is far from what you were expecting. And that might be for several reasons. There's also a lack of flexibility, usually. So previous models to Prometheus 2, specifically fine-tuned for performing evaluations, they could only do one type of evaluation. For example, pairwise ranking. So choosing which output is the best between two, or direct assessment of output grading. So basically assigning scores. They couldn't do both because they are specifically fine-tuned for that single task. So that's another problem as well. And even bigger problem is that they are not customizable based on some evaluation criteria. And that limits a lot the applicability of those models, because if you are operating in a different domain, you have different evaluation criteria, that's going to be like a really important problem, a limitation. How they basically approach this is they look at the different models available, and what they wanted to do is basically to create a model, an open evaluator that basically shows high correlation with the strongest evaluators out there. And the strongest evaluators out there are obviously humans, GPT-4, and Claude 3. Because obviously humans, we know we can do evaluations. Then we have GPT-4 that we know that shows high correlation with human evaluations. And then we have Claude 3 that, same as GPT-4, is a really strong model that could perform evaluations as well. And now, fortunately, we have Prometheus 2 that basically shows high correlation with all these three, with the human, with GPT-4, and with Claude 3. And that's really big step, because in the past we had these basically weaker evaluators, like Prometheus, like the first model that they trained, Prometheus 1, let's call it 1, Llama 2, or GPT 3.5. We see that those show really low correlation with the stronger evaluators. Another interesting thing that they did in this paper is that they experimented with model merging. They are saying that to close the gap with proprietary language models, they investigated unifying two model-based evaluation paradigms. So one is the direct assessment and another one is pairwise ranking, and we are going to look at them in a second. But what they did is, instead of training one model on both tasks, so kind of multitask learning, they basically train two separate models, single task models, one on a dataset for direct assessment and another one on a dataset for pairwise ranking. After that, they merge the weights of those models, and they experimentally saw that that resulting model actually outperformed the jointly trained model, and it's basically much more robust. and also obviously brings that flexibility of having a model that could do direct assessment and pairwise ranking as well. So that's a really, really interesting kind of approach to the creation of this model, and we are seeing a lot of model merging recently. We could have another video about that if you are interested in, so just feel free to leave a comment. But yeah, pretty cool that they are actually experimenting with these new techniques for building robust and smarter language models without not much compute. The data that they use was synthetically created by them. So one is the preference collection dataset, another one is the feedback collection dataset. So the feedback collection dataset was created for the first version of the Prometheus model in another paper. So basically, they curated a few seats where they included like rubrics and evaluation criteria that, from their point of view, was important for evaluating language models in this case. And then from there, they augmented those rubrics using LLMs. So basically, if you have like a bunch of rubrics here that you curated, you could use GPT-4 or any other. I think that you use GPT-4 in this case to basically augment these to, let's say, 1K rubrics. And then next step for them was basically, okay, now let's synthetically generate inputs, basically instructions that are relevant for this kind of rubrics and this type of evaluation. And I think, if I'm not wrong, they generated around 100K instructions. And then the next step is basically generating the responses, basically. And that's the feedback collection dataset and the thing that they use GPT for all of this, if I'm not wrong. But anyways, synthetically generated dataset, in this case for direct assessment. So this was in a Likert scale, basically, from 1 to 5, where 5 is the best score and 1 is the lowest score. For this model, as they wanted to do pairwise ranking as well, what they did is they modified the feedback collection dataset and created the preference collection dataset, which is a new fine-grained pairwise ranking feedback dataset that builds on the feedback collection dataset. So they just basically, again, they synthetically generated data, they created different combinations, and they use kind of GPT-4 for creating this new data where you have one input, two answers, and then which one is better, it's A or B, with some verbal feedback. And we'll see how basically the direct assessment and the pairwise ranking evaluation tasks look like in a second. Before we move on, just to point out that they choose Mistral 7B and Mixtral 8 by 7V as the base model, and then fine-tune these ones, basically. Let's look at the methodology, so basically at the evaluation tasks that they decided to use, and let's look at this example as well that we have here. So, as we said, we have first direct assessment. For direct assessment, we have the feedback collection dataset. And then for pairwise ranking, we have the preference collection dataset. So the direct assessment evaluation task is basically mapping an instruction and a response into an scalar value or a score S, basically. It's as simple as that. So you have an input, you have an output, and then you assign a score S. They are specifically using a Likert scale, scoring from 1 to 5, where 5 represents the maximum possible score for that evaluation. This is good practice. In general, you don't want to go like to continuous scoring scales. It could have been like 1 to 3, for example, 0 to 3. It depends. In this case, they made this decision, and I think it's a good one. And they took some evidence from previous research to try to maximize the correlation with human judgment, obviously, which is what we want. One of the decisions was to include a reference answer A as an input as well. So you have the input, you have the response, and then you have a response reference. So the evaluator could compare those and base the evaluation on that. They also decided to include verbal feedback, VR, here. So because it was proven that this also increases the correlation between the language model and the human. So this would be like something like prompting the model to explain why it's assigning that specific score to that instruction response pair. Additionally, they also added as an input evaluation criteria. And this is really nice because then users could define different evaluation criteria that is going to steer the evaluations, and potentially it's going to maximize the correlation. Then pairwise ranking, quite similar, but in this case, it's mapping an instruction and two pair of responses into either response A or B. So instead of using a scalar value for the score, in this case, just choosing one of those responses. And they also included a reference answer, verbal feedback as well. In this case, they also actually included evaluation criteria, as we can see here. But it's not really a set of, what they are saying is that in this case, it's not a set of descriptions for each score, because there's just two score. It's more like description of the evaluation criteria itself. Let's look now at this example that we have in the paper, where we have this input in the field of software development, what's the meaning, blah, blah. And then we have two responses. In pairwise ranking, we are going to take the two responses, and then there's going to be this evaluation criteria that you can see here. In this case, is basically asking if the response accurately use specific industry terminologies and jargons. And then what we are doing is prompting the model to output this verbal feedback that is basically explaining how to evaluate this specific data point and how it's choosing basically the answer V in this case. So the scoring decision could be. Then on the right hand side, we have direct assessment, where we are just taking one response because we don't pass two responses in the direct assessment evaluation task. And basically, the verbal feedback is explaining why this response A should have a score of 4, in this case, out of 5. And then the scoring decision would be that value, 4. Let's wrap this up by looking at the results for the direct assessment task and also the pairwise ranking task. In a nutshell, what they are saying is that the Prometheus 2 models, both the 7B and the 8x7B, strongly correlate with the standard or the reference LLMs for evaluation, like GPT-4, Claude, and also with humans, basically. So on average, it's usually a Pearson correlation score higher than 0.5, which means moderate to high agreement. And if we look at this table here, we can take a look at the results. So at the top, you have the reference evaluators like GPT-4 and Claude, and also humans were available. And then each row is either an open source evaluator or a weaker evaluator. For example, we can see for Vicuna Bench, we have Prometheus 2 8x7B as the best performer. Second best is basically Prometheus 2 7B. And that's the same for basically, best performer among the open source ones. What this value means is the correlation with the standard one. So basically, correlation between these two. Prometheus 2 is the one that shows the higher correlation among the open source models. So that's how they basically evaluated this. It's not that it's outperforming GPT-4. It's that it basically shows like high correlation. Also with Claude 3, same for Empty Bench, same for Flask, and then for Feedback Bench. Also, let's point out that Feedback Bench, it's basically an in-domain dataset for Prometheus. That's important. So pretty good results, high correlation with standard, strong, closed source language models. So it's a big step towards having strong open evaluators. For pairwise ranking, it's the same. So if we look at the results here, in this case, these numbers represent accuracy on the human preference datasets. And then we see strong performance for Prometheus 2, 8x7B, and 7B as well. We can see here these values. Quite good results compared to other open language model evaluators, with the exception of Ultra RM and Per RM, but it's important to point out that these are in-domain test sets for these models, so something to consider. So overall, I think that this is a really interesting paper. I think that we are gonna see more of this in the near future. I think that there is a need for specialized small evaluators, LLM evaluators, as an alternative to using closed source language models for evaluations. Hope you enjoy it. And if you have any comments, any feedback, any questions, just send them to us and we'll be more than happy to discuss them. Thanks for watching or listening. Take care.